Hi everyone, I'm Kiran, and the topic of this video is blockchain in cybersecurity. So let us begin. What is cybersecurity? The process of preventing cyber attacks on network, system, or applications is known as cybersecurity. It is used to prevent identity theft, cyber attacks, unauthorized data access, and cyber threats. With increasing reliance on technology and data, it has become very important to reinforce our security measures to protect digital data and transactions. So now, what is blockchain? Blockchain is a shared, decentralized, and digital ledger that records transactions in the form of blocks. This ledger helps us to store information transparently due to its property of immutability. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. In this way, a blockchain is a foundation of immutable ledgers or record of transactions that cannot be altered, deleted, or destroyed. So now let us discuss some use cases of blockchain. Integrity of software downloads. Blockchain can be utilized to verify updates and installers to prevent malicious software from infecting the devices. Here, hashes are recorded in blockchain and new software identities can be compared to the hashes to verify the integrity of the downloads. Next is ownership validation. Proving ownership of online assets was difficult before the existence of digital ledgers. Even in physical world, deeds can be destroyed. Certifications don't always hold up and millions of people have access to stable government identity or financial services. Now, just as non-fungible tokens (NFTs) enable artists to digitally watermark their media, the ability to create an immutable record of authenticity and ownership with cryptographic keys has numerous security benefits across many blockchain use cases. For example, students and teachers can own their credentials regardless of jurisdiction, reducing counterfeit certifications. Creators can maintain their full rights over their media, improving copyright protection. Property owners can prove the title and delegate rights. Manufacturers such as luxury brands can attach NFTs to their goods to ensure authenticity. Next is data integrity and transmission protection. Data on blockchain can't be altered because network nodes cross-reference and build upon each other and require consensus to verify transactions. Data off-chain, however, can be corrupted. This is where on-chain signatures can enable new blockchain use cases where security is paramount. Decentralized voting, health, and scientific data collaboration across institutions and decentralized metadata, which is now important for optimizing artificial intelligence in cybersecurity. By using an encryption, the data in transit can also be protected from unauthorized access. Next is traceability and provenance. Transparency and traceability are core to blockchain designs, but their security benefits manifest differently in different applications. For example, in a supply chain context, a digital distributed ledger stores tamper-proof records of transactions and free data across parties and product lifestyle cycle. This reduces the risk of counterfeit and tampering by any single party. In financial use cases, transparency and immutability of payment history reduce the need for a central broker. Blockchain can also improve security and privacy of transactions such as remittances and cross-border payments. The next important use case is mitigating DDoS or distributed denial of service attacks. One of the most popular cyber attacks today is DDoS attacks, where hackers aim to generate flood of internet traffic and thus disrupt flow of services. The property of immutability and cryptography help blockchain to prove to be an effective solution for these attacks. Then it is decentralized storage of critical data. With exponentially increasing data generated every day, blockchain-based storage solutions help achieve decentralized storage, thus protecting digital information. So now the application of blockchain in CIA. What is CIA? In cybersecurity, CIA triad model acts as a reference to assess the security model of an organization. CIA mainly consists of three parameters: confidentiality, integrity, and availability. And blockchain helps us ensure all these policies are satisfied. Confidentiality. It means to ensure that only interested and authorized parties access the appropriate data. Full encryption of blockchain Blockchain data ensures data will not be accessible by unauthorized parties while flowing through untrusted networks. Security measures such as access control should be implemented directly at application level so as to prevent attacks from within the network. Blockchain can also provide advanced security controls by using PKI or public key infrastructure to authenticate parties and encrypt their communication. However, backup storage of private keys in secondary storage poses theft or of private keys as high risk. To prevent this, key management procedures such as IETF or RFC and cryptographic based algorithms can be used. Integrity. Blockchains built in characteristics of immutability and traceability help organizations ensure data integrity. Consensus, consensus model protocols can further help organizations to implement mechanisms to prevent and control ledger splitting, even in the event of 51% cyber control attack. In blockchain, with every new iteration, previous state of the system is stored and thus providing a fully traceable history log. Smart contracts can also be used to verify and enforce rules between parties, preventing miners from mining blocks of data. Availability. In recent times, cyber attacks attempting to impact technology services availability are on the surge, with DDoS being the most common type of attacks. However, in blockchain-based systems, DDoS attacks are costly as attackers attempts to overpower network with a great number of small transactions. Blockchain have no single point failure, which decreases its chances of IP-based DDoS attacks, which disturb the normal operation. Data remains available through various nodes, and thus full copies of the ledger can be accessed at all times. Combination of multiple nodes and distributed operation makes platforms and systems resilient. Now, some pros of blockchain in security. First is decentralization. Because of P2P or peer-to-peer network, there's no need of third-party verification. Data transparency and traceability. History of all transactions is maintained and thus can be traced at any time. Transaction data is digitally signed by members of blockchain network, thus maintaining transparency. Confidentiality. Confidentiality of network members is high due to public key cryptography that authenticates users and encrypts transactions. Secure data storage and processing. Blockchain's major feature of immutability and records of any changes to help data store the data in a safe and secure manner. No single point failures. Blockchain systems are decentralized. Thus, single node failure doesn't affect the entire network. Thus, even during DDoS attack, the system is not compromised due to maintenance of multiple copies of ledgers. Smart contracts, software programs that are based on ledger. These programs ensure execution of contract terms and verify parties. Blockchain technology can significantly increase the security standards for smart contracts as it minimizes the risk of cyber attacks and bugs. Safe data transfers. The public key infrastructure PKI in blockchain maintains authentication during data transfers. Smart contracts help with automatic execution of agreements between two parties during a transfer. Now let us discuss some cons of blockchain. Irreversibility. There is a risk that encrypted data may be unrecoverable in case a user loses or forgets the private key necessary to decrypt it. Adaptability and scalability challenges. Blockchain networks have preset block volume and limits to transactions per second. So it becomes very important to check the scalability of the network. Integrating blockchain technology requires a complete replacement of current systems, and thus companies may face difficulties in doing so. High operating costs. Blockchain requires high computing power and storage capabilities. This leads to higher costs as compared to non-blockchain applications. Storage limits. Each block can contain no more than 1 MB of data, and the blockchain can handle only 7 transactions per second. Thus, storage is limited in a blockchain. Blockchain literacy. There are not enough developers with experience in blockchain technology and deep knowledge of cryptography. Lack of governance. Blockchain concepts aren't regulated globally yet. Regulations and frameworks need to be developed in order to maintain governance in blockchain applications. Now, some real life examples. Cryptocurrency trading companies like Coinbase, MobileCoin, Javi, and Founders Bank use them. Banking sectors, even like JP Morgan Chase, Santander US, and Barclays. Some patient health record companies like Philips, HashHealth, Health Linkages. It is even used by military and defense data managing companies like Lockheed Martin, Defense Advanced Research Projects Agency, DARPA, and Some companies which manage IoT, that is Internet of Things, like Cisco, HDAC, Sage Security, Grid Plus, also use them. Future of blockchain in cybersecurity. Blockchain is a breakthrough in cybersecurity for digital world and will ensure that CIA triads of cybersecurity are being followed. The complexity of its implementation may, however, lead to some difficulties for application. Given blockchain's various applications, such as facilitating transactions and storing data in a more secure manner, the financial services industry stands to benefit greatly from its growth. Emerging technologies such as permission blockchains can help achieve the important goals of combating cybersecurity risk and adequately protecting consumers' financial information and integrity of global financial system, such as cyber threats to industries. Thank you.